Okay? All right, so probability experiment. Here we are, 132, right? Okay, so probability experiment. Now the basic concepts of probability. Some are going to be pretty good, pretty easily understood. Others are going to be rather challenging. Okay, it gets a little tricky as we move along. This chapter only takes like 2 weeks, so we should be done by the end of the first quarter, I would think. Okay, so your probability experiment, it's an action or trial through which specific results, counts, measurements, or responses are obtained. Okay, and that's right in that little box there on page 132. So your outcome is the result of what? Of a single trial. Okay, good. The sample space is the set of all possible outcomes of a probability experiment. Okay, and the event is a subset of the sample space. So these are terms that they will use in their explanation and the writing. These are terms that I will use on quizzes and tests of things that you will have to find. Now, when you identify a sample space, if you have to list them, what is available? Now, they're not going to give you something so extreme that has, 100 possible choices in the sample space. But if we do it very simply, okay, like we start with the coin, and if it says list the sample space, what can happen when you flip a coin? What outcomes? No, what outcomes when you flip a coin? Heads or tails. That's what they're talking about, okay? So you're right, it's a 50-50 shot, okay? But the coin toss, you can have a head or a tail. And there'll be times when you don't have to write it all out, okay? When you talk about marbles, like you saw back in Algebra 1, blue marbles, black marbles, okay, you have to definitely differentiate between the blue and the black, okay? You can't just put BL and BL, because I don't know what you're talking about. Now, the people in this statistics class, what would you have to do? You'd have to list them. So you'd have to start all the way with B. Riggs, and then go all the way to Rebecca. Uh-oh, Rebecca, I hope I don't spell your name wrong. Is that right? All right, whew, that was a close one. All right, and then you would list everybody, okay? And like I said, sometimes my stats classes are small, sometimes they're a little larger, but just an example, okay? And then C, the last one, is rolling a fair die. And they'll always say a fair die. What's that? Yeah, 1 through 6. So you would just say 1, 2, 3, 4, 5, 6. Okay, so that's nice and easy to list. Okay, so that's when you're identifying a sample space, what can happen, or who can be chosen. Okay. All right, now, when you roll 2 die, you have to be very, very careful about this. All right, so when you think about this, you want to think of rolling maybe a red die and a green die. Okay, so they're 2 different colors. So that way, if I get a 2 on the red and a 3 on the green, that's different than a 3 on the red and a 2 on the green. Okay, because both of those can happen, and their sum is the same. What's their sum? 5. Okay, so that can both happen. So how many outcomes make up the sample space? Well, when you're rolling 2 die, okay, how many options do I have for the first roll? 6. How many for the second? 6. Okay, so there's 36 possible outcomes. Okay. Now, if roll of 5 was an event called A, how many possible ways can you do that? So sometimes you're going to have to list what can happen, like we did previously, and then you can determine, oh, okay, this is how many ways it can happen. And when you list them, you want to do it in some systematic order. So if I have event A, okay, which is rolling a 5, I can have, and again, we're thinking of the red and the green die. Okay, always start, okay, I'm going to start with the lowest number. You can start with the highest if you want. So I can have a 1 and a 4. Okay, I can have a 2 and a 3. All right, and then you see I'm going up by the first one. Then I can have a 3 and a 2, and then a 4 and a 1. Okay, can I have a 5 and a, no, you can't. Okay, because you can't have 5 and a 0. Okay, so now how many possible ways can you do that? 4. So you see what I mean? So sometimes you guys have to show some work, and then always go back and read what the question is asking you. Okay, so go back and, oh, we figured it all out. We got this. Now did I answer everything? Because on quizzes and tests and assignments, every single thing has a point value. Okay, and if you forget it, then you're going to lose points on it. All right, now this was something, we don't get into the gambling stuff. And part C is very similar to B, but I want to roll a 7. So how many possible ways can I roll a 7? So why don't you see if you can list them? Okay, so again, you list them. Of course, you have to start at 1 and stop at 6. So how many possible ways can I roll a 7? 6 possible ways. Okay. In the first chapter, like I said, it's a lot of introduction, just the foundation. So I know it's kind of boring, you know, listening to the lecture and everything, but we got to get through it all. What's up? Yeah, go ahead. Okay. All right, now your fundamental counting principle, kind of like what I just showed you when you found the sample space of rolling 2 dice. Okay, so find the number of ways you can complete each task and multiply them together. So just like we did in the first one, okay, we had 6 choices for the first, 6 for the second. 6 times 6 was 36. And again, this is all back like in Algebra 1. You know, and there's even some of this in Algebra 2. Okay, so we flip a coin and roll a die. How many possible outcomes are there? So we flip a coin, roll a die. Okay, because you don't want to miss anything that's going on. All right, so what are the outcomes for flipping a coin? 2, right, okay. And then rolling a die, 6. 2 times 6 is 12. So how many possible outcomes are there? 12. All right, so sometimes they'll ask how many, sometimes they'll ask list, sometimes that's whatever. Okay. Now, 2 types of sandwiches, 4 drinks, 3 desserts in a cafeteria. How many possible meals can be made using one of each item? So we have our sandwiches, our drinks, our desserts. Sandwiches, 2. How many drinks? 4. And then how many desserts? 3. Okay, so you multiply everything together, however you want to do it. 2 times 4 times 3, 3 times 4 times 2, whatever, and you get 24. So 24 possible meal selections. All right, types of probability. Now the types of probability are on page 136 and 137. Okay, so when you see my shorthand, when I do what the formula means, you can look in the book and see exactly what it means. So you have what's called classical or theoretical, meaning that should happen in theory. And then you have empirical or statistical, which is what you observed. Okay? So when you're talking about the classical probability, sample space is equally likely to occur. So that just means what should happen. Okay? So if I roll a die 6 times, what should happen? I should get a 1, a 2, a 3, a 4, a 5, and a 6. That's what should happen. Okay? Because 1 out of 6. Does that happen all the time? No. Okay? So that's what, so classical is what should happen. Empirical is what actually did happen when you rolled the dice 6 times. So you can see with the probability of E, it says the number of outcomes in event E, okay, which is right on that page 136, over the total number in the sample space. Okay? And here's an example of it. So you roll a fair die. What's the probability of rolling a 3? So the numerator is the number of outcomes. How many ways can I roll a 3? Just 1, just the 3. And the total in the sample space, there are 6. And they always say a fair die. Okay, not a loaded die, weighted die, whatever. Okay? And then the probability of rolling a 7, okay? Because it only goes up to 6, so can't have a 7. So it's 0 over 6 or just 0. Can't happen. Okay? And then you got to be careful of your terminology. This says less than 5, so is 5 included? No. Okay, so be very careful. So less than 5, we're talking about 1, 2, 3, and 4. So rolling a number less than 5 would be 4 out of 6. Now, if you want to simplify, go ahead. Okay, you don't have to. Probability is the only thing you don't have to simplify. Okay, so you can just leave it as 4 out of 6. Okay? And what I recommend, though, is if you're going to simplify it, I'd put it in your calculator. I'd want to put 4 over 6, enter, and have it spit out the fraction. Sometimes you guys maybe get a little careless, and I don't know, you make it 1/3 by accident. Okay? Just be very careful when you're simplifying. Now, the other thing I talk a lot about is cards. Okay, is everyone familiar with a deck of cards? Okay, how many? Yeah, 52 cards in a deck. How many suits? How many suits? 4 suits. Okay. What are they? What are they? Yeah, diamond, heart, clubs, and spades. Should be a dealer. He's a dealer up at the casino. Okay. No. Oh, yeah. Oh, cool. That's good. That's a good hobby. Yeah. But you know something? But if you win, you're in big troubles. Yeah, you are. Because I had a student back in like 2005 or 2006 who went to the casino, and he was at a table and he won, I don't know, like $6,000-7,000. And guess what? And you can't claim it. You can't claim it. Doesn't matter. You can't claim it. No, you can't claim it if you're under 18. You can't. Not. I mean, maybe $100 or some big deal. But yeah, big shot. No, you're not getting it. They go look at the cameras, and then he tried to give it to his buddy who was 18. Didn't work. You know what they did? They said, "Oh, thanks for coming. See you later." And they put it in their pocket. It's the American way. All right. Okay, so here we go. So with the cards, all right, now remember you got kings, queens, and jacks. Those are called what? Those are face cards. Okay, so you got to be very careful. I try not to do too much with this because I know some people are more familiar with cards than others, but you'll see this in the book. Okay, so a standard deck of cards, of course, we'll say a standard deck, okay, meaning 52 cards. Selecting the 7 of diamonds. What's the probability that happens? Yeah, 1 out of 52. Okay. Selecting a diamond. How many are there? 13. And if you forget, you can just do 52 divided by 4, 13 over 52. And then selecting a diamond, heart, club, or spade. Okay, 52 out of 52, which is 1. Okay, so we saw a couple things here in these examples. The first thing we saw, well, not the first thing, but one key is example 1, letter B, where you have a 0. Down here, example 2, letter C, you have the 1. So what is all probability between 0 and 1? Okay. All right, now here's your empirical, and that's on 137. So your empirical is where you actually did something. So this is based on observations, okay, based on observation rather than theorizing. So what actually happened? So the probability of E, you have the frequency of the event E over the total frequency. Okay. The insurance company determines that every 100 claims, 4 are fraudulent. So what's the probability that the next claim of the company processes will be fraudulent? 4 out of 100, which is 4%. And that's what they think should happen. Okay. Will it always happen? No, of course not. I know a lot of notes today, a lot of notes. We're almost there. All right, this stuff is on, okay, law of large numbers, 138 to 139. Okay, so with the law of large numbers, okay, this is like the data that we've collected in chapter 2. Okay, the more data you collect, the more accurate your responses will be in terms of the mean, the standard deviation, okay, and lining up. Okay, so law of large numbers, and as an experiment is repeated over and over, the empirical probability of event approaches the theoretical probability. Okay, so if you roll a die 6 times and you get 3 threes, okay, so your empirical probability, okay, what happened is 3 out of 6, okay, 1/2, not likely to happen. If you keep doing it more and more, maybe you roll it finally 600 times. Okay, you'll see, oh, I got 100 of them instead. So it gets closer and closer. Now your subjective, the third one, probability results in intuition, educated guesses, and estimates. So you're just using prior knowledge. So a doctor may feel the patient has 80% chance of recovery, okay, based upon what has happened in the past. Business analyst makes prediction that the chance of employees in Utica McDonald's going on strike is 0.3, okay, because of what happened or whatever else, okay? Now, we have 3 probabilities on page 4 of your notes. You know the type of probability. And these are the same things on page 139 at the top. Take a minute to read them. There you go, the 3 of them. 1, 2, 3, A, B, C. Okay, so this is another example of if you are taking notes on your own. Okay? It says the probability that you'll be married by age 30 is 0.5. What type of probability is that? What do you think? That's subjective. Okay? So you might say, well, I think it's subjective. I'm not really sure. So remember, the solution for the top is right underneath. So the probability is most likely based on an educated guess. It gives you a reason why. It's an example of subjective probability. So when you have notes that you have to take on your own, and I usually give you the types of probability that are in the example. Okay? And then the probability that a voter chosen at random will vote Republican is 0.45. That is what? Empirical. Okay? And why? Because based on a survey, okay, of voters. And that could change depending on where you are. And then the probability of winning a 1,000 ticket raffle, and change that, okay, should be 0.001. Okay? So the probability of winning, all right, that is your classical. That's your theoretical. All right? 1 in 1,000. Okay, 0.001. Okay. And then we have some rules. We've kind of seen a couple of them right here. So the probabilities between 0 and 1, like we've already established. Okay, probability of A. They use the probability of E, which is the same thing. Okay, between 0 and 1, inclusive. So we already saw you can have 0, you can have 1. The sum of the probabilities of the outcome must equal 1. And we saw that with the die. So if we roll the die, 1, 2, 3, 4, 5, 6, everything had a probability of 1 over 6. So if you add all those together, you get 6 over 6. Okay, so that's the sum of their probabilities equals 1. This right here, we're going to get more into this in section 3.3. Okay, 2 events have no outcomes in common. Then they are disjoint or mutually exclusive. All right, so I'm not going to spend a lot of time about this one. It's the addition rule. Like I said, we're going to see that in 3.3. Okay, and talk about it. It does say disjoint. Are they mutually exclusive? Okay, and that's where it gets real tricky. Okay. Now, the last one here, number 4, it's your complement. Okay, and they have here AC, a complement. The book will also use the probability of A prime, which is 1 minus P of A. Okay, and that's your complement. So if I have the complement plus the probability, it should equal 1. And if I tell you the probability of event A that you will have physics homework is 0.82, find the complement. So my complement is going to be 1 minus 0.82. Now, sometimes you want to make sure you put some of these basic mathematical equations in your calculator. All right, because I don't want you to do this and tell me it's 0.28. All right, so be very careful of that. All right, so if you do that in your calculator, so the probability of A complement is going to be 0.18. Okay, so this right here is the probability of event A occurring, which is 0.82. All right, so if I take them and add them together, I get 1. So you will either have physics homework or you won't have. Okay, and then one more page and that's it. All right, and then tomorrow's a work day. Okay, so tree diagram. So when you list the sample space, or they want you to draw a tree diagram. All right, there's different options. Now, this one here, be very careful. Family is planning on having 3 children. Okay, it's not just 2 times 3. Right? You got to be very careful of that. All right, so we want to make the tree diagram. So I start over here. You can watch first and then try to squeeze it in. Okay, so a tree diagram, and you can do it from the top down if you want. I just find it easier to go across. So my starting point is with 0 children. So I have 1 children. I have a boy or a girl. Okay, now my second child, boy, girl, girl. And then the third child, off of each one of these, are another 2 branches for your boy, girl, boy, girl, boy, girl, boy, and girl. Okay, so that's your tree diagram. So take a look and squeeze it in there. A lot of times they give you an option. Either make the tree diagram or list the sample space. Okay, now from this. All right, so the first thing you want to determine is what is the sample space? How many outcomes are there? 8. Okay, now how could you have found that? So we have 3 children, 2 choices, all right? So then you have 2 times 2 is 4, times 2 is 8. So that's your sample space. Like I said, it's not just 2 times 3, which a lot of students do. And then you the end, okay, and you follow the tree down. So what is the probability of having 2 girls and 1 boy? So you come here and look, I have boy, boy, boy. No good because I need 2 girls. Then I have boy, boy, girl. See, I'm right down here. Then I have boy, girl, boy, boy, girl. There's one right there. Okay, boy, girl, girl. So that's 2 girls and 1 boy. Then I have girl, boy, boy. Nope. Girl, boy, girl. Yes. And then girl, girl, boy. Yes. And then girl, girl, girl. Okay. So the probability of having 2 girls and 1 boy is 3 out of 8. Because that's the total possible outcomes right here of what you can happen. Okay? And this is here, this is the first child, boy or a girl, boy or a girl, boy or a girl. Yeah, you probably did. So I'm saying I know it was on Algebra 1. So it's nice to have something easy for a little while. Then it gets yucky. Okay, what's the probability of having 3 boys? 1 out of 8. Okay, and the only way it can happen is boy, boy, boy. And then they get into other questions. The girls are oldest, okay, boys the youngest, whatever. Okay, so if I have 1, 2, and 3, who would be the oldest? Ones. Okay, the ones would be the oldest. Okay, because they're first. So you got to be careful of that too. Okay, and then here's the last one. High school ID number consists of 9 digits. First 2 digits of each ID number will be the last 2 digits of the year you graduate. The other digits can be 0 through 9. Each digit can be repeated. Probability of your ID number will randomly generating the other 7 digits. Okay, so we have what? 9 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9. And these are just the fundamental principles. Okay, we're going to, yes, get into formulas. So the first 2 digits will be the last 2 digits of the year you graduate. So we guys are what, maybe 20, 21, whatever. So how many options do I have for this first number? Just 1. And how many for the second number? Just 1, because it has to be 20, 21, 22, whatever. Okay? But now I have the other digits can be 0 through 9, and this is key. They can be repeated. I don't know why I got large on this on here. Okay? So how many numbers are there between 0 and 9? 10. Okay, be careful. It's not 9, but there's 10 of them. then you have 10 times 10 times 10 times 10 times 10 times 10. Okay? So we have 1, 2, 3, 4, 5, 6, 7 zeros. So 1, 2, 3, 4. Of course, if you want to put that in your calculator, you could. Now this 10 million, okay, this is how many, what are they? IDs you can have, how many ID numbers you can have, okay? So you got to be very careful, all right? What do they want? They want the probability. So the probability of getting your ID is 1 out of that. 1 out of 10 million. Mm-hmm, it is. But a computer can do it quick and get it, you know, and find your password and whatever else. Okay? That just means it could be anything. Yeah, it doesn't have to. Yeah. Yeah, and it's not repeated, you know, so it's just randomly generated. However, it's computer generated or whatever. Okay? All right, and then the classwork we'll work on tomorrow while other people are getting these notes.